Okay, good afternoon, everyone. Can everyone hear me? And can everyone on Blue Jeans hear me? Can somebody who's on Blue Jeans respond and confirm they can hear me?
Yes, I can hear you.
Excellent. Is that Gregory?
Yes, it is.
Great. Okay, thank you for coming to this session. We're going to talk today about early science. So this is the science that we hope the community will be able to achieve in the pre-operations and early phases of operations. So I'm not going to go through these. I think most of you have seen these. Just friendly reminders about COVID and virtual participation. The 2-meter rule applies. I am 2 meters away from you. I'm going to take my mask off to speak. I will put it back on when I come to you. So it's very hard to speak clearly through a mask. Okay, so Bob and I are going to co-chair this. We have a Slack channel. I would ask that people please ask questions and discuss in the Slack channel. Please don't type your questions into the Blue Jeans chat. Nobody's monitoring the Blue Jeans chat, and it's good that we keep everything all in one place. We can see the discussion, everyone can contribute, and we also can save that history of discussion for after the session and go back to it and use it as a reference. Please also try to remember to discuss in threads. If somebody asks one question, then somebody asks another question. Keep the discussions about topics in threads, otherwise Slack can very easily become a nightmare to manage. Our scribe is Phil, and there is a shared Google Doc that is linked to the session as a bookmark in Slack. If anyone has any notes or things that come up of particular interest they'd like to contribute or add, this document should be writable by anyone. So please add your notes if there's something you think you'd like us to take away from this. Okay, I'm going to use this. Can people on Blue Jeans still hear me?
Yeah.
Yes.
I think this microphone's okay, good. Okay, I'm going to start with a definition of early science. This is because I've heard a lot of different definitions from people, and I think there's a little bit of confusion in the community. I did put out a form to solicit early questions for this session, and some people did respond. Thank you very much to whoever you are. You gave us 3 very nice questions and helped us to shape this session. One of those questions was, what is early science? What is the definition of early science? So we define early science, and Bob actually said this in his plenary this morning, I think, is defined as any science enabled by Rubin for its community through and including the first data release. That's data release 1. So this includes data preview 1, which will be based on ComCam data, data preview 2, which will be based on LSST cam data, and data release 1, which will be based on the first 6 months of data taken with LSST, released 1 year after the start of the survey. So it takes 6 months to process 6 months of data. Data preview 1 is currently foreseen for release somewhere between March and July of 2024. I have date ranges here. This indicates uncertainty within the construction project. There is some uncertainty on when we'll have data with ComCam, and hence that is a knock-on uncertainty to when we'll be able to process that data and release it as data preview 1. So this is a range of dates for the release of data preview 1. It's not a range of dates for the acquisition of data with ComCam or LSST cam. Likewise, for data preview 2, that's foreseen for between December 24 and March 25. Data release 1 is foreseen for between October 2025 and January 2026. And in addition to these 3 data releases, which will be based on data release processing, we will have alerts of some form. And that is that, well, just to note, there's a note down here. We won't be able to produce alerts or run alert production at full scale or full fidelity in year 1, nor in commissioning, because we won't have templates yet that cover the whole sky in all filters. So any alert production and any alerts that are released in the first year of operations will be at reduced scale and fidelity, and they will be facilitated by whatever images we acquire during commissioning, which we will use to build templates, and we will use those to do difference imaging in year 1. We will also run something called incremental template generation in year 1, which means that we won't wait for a full year to start making templates. We will build templates as soon as we have sufficient images of sufficient quality in a given filter for a given pointing, and then we will start to use them immediately to do difference image analysis for the rest of the images in year 1. So I want to just pause there and ask if there are any questions on that.
Number of exposures to get a good template?
Yeah, that's a good question. Who was that? That's Kevin, I think. That's a good question. So we have a requirement on the noise that a template can contribute to a difference image. If you take those numbers and you work out the number of images that corresponds to, in the first year of observing, that's 3 images. And in the second year of observing, the requirements are tighter. That comes to 5 images. Okay, wonderful. I hope that's clear.
Yeah, thanks.
So, in order to help define and communicate what is early science, we've started a tech note. It's called it's RTN 11. It's the roadmap for early science. This is a guiding document for all early science with Rubin. We issued an early version of this, a first version rather, of this last year in order to support people applying for grants. It has a DOI, and you can cite it. The DOI is here, and you can cite it as such and include it in your research proposals. And it's primarily to communicate what is early science to the community and to help support the community in their proposals, their grant proposals. This document provides plans for the early science program. It outlines the strategy for obtaining observations during commissioning that will be used to enhance early science. And it describes the plans to implement incremental template generation in the early phases of the survey. We intend to release a new version of this document by the end of August, and it will take into account all the feedback we received during this session from the community. Do you want to talk about this? Bob and I are sharing our co-chairing duties here.
So thanks, everybody. Welcome. Good to see you all here. Data release schedule and content. So the takeaway for this diagram is much the same as I covered in the plenary this morning. There's a range of dates where we are expecting to deliver data products to the community. This actually shows you in this nice diagram, there's a successive addition of data products as we go through this pre-operations phase, the commissioning phase, early operations, and through into the regular data releases. So you can see that we're adding things successfully as we go through in time. Just as I said, and you see the current date ranges that are consistent with what we have said earlier. What I said again earlier this morning was that this is one thing to have a schedule, but then you also want to know what the content of what goes into those things and what it actually looks like. What was the strategy to arrive at those observations that lead to those data previews and data releases? And as Leanne has just described, there's considerable uncertainty because we won't have covered the sky at all the way through data release 1. So there's many choices to be made. That's what we want to do with you. We want to collaborate with you on deciding what the best way to do each one of these phases is so that we get it as right as we can. This is between us. We don't want to just say this is what we're doing and that's the end of the story. But what we have developed and what that RTN 11 document talks about is a framework where we can start actually having maybe more quantitative or detailed discussions about how this could look, what the issues are, and how to work through them.
So this is me, but I'm going to, I was going to do this, but since Keith Bechtel is here and he is our science verification lead in commissioning, I'm going to ask Keith to speak to this slide.
Thanks, Leanne. So if you were at the science verification validation session this morning, you may have seen this slide already, but I'll talk through it here again in the context of operations and early science. So what is intended here is a schematic of the plans for data taking, both with ComCam and with LSST cam during commissioning. So time is moving from left to right, and there's a row for ComCam and a row for LSST cam. So the different colored boxes represent different phases of commissioning. And so initially, with both ComCam and LSST cam, there's a stage of collecting electro-optical data, but the part that we'll focus on in terms of the interesting science data products for early science is once we go on Sky. So what's indicated on each one of these phases is the approximate duration of time based on the current schedule. So you'll see that here. So with both ComCam and LSST cam, there is an initial phase when you first go on Sky that we refer to as the on-Sky engineering. So this is a period of roughly 3 months that starts off as primarily engineering type work, but will gradually transition to being more science-driven in terms of the duty cycle. The example observations that would be taken during this time include, for example, optical alignment, pointing tests, tests of the active optic system, and then as we're getting closer, closer to the end of this period, transitioning to taking star flats. So that would mean taking roughly an hour, taking dozens of visits that are all dithering around the same dense star field in order to test your astrometric and photometric calibration, basically the calibratability of the survey. And this basically marks what we call first light. After that period, we go to a phase of system optimization. And the current plan during this phase is to focus on taking a handful of fields to something like 10 to 20 year equivalent total exposure relative to the LSST wide fast deep survey. So we're imagining maybe 3 different contiguous fields, each made up of a handful of pointings with a total of something like 100 square degrees, and taken to 20-year equivalent depth and as many filters as possible. You could collect this data in something like a month or so. With ComCam, the degree to which we'd be able to do this is somewhat dependent on schedule, but this is basically an essential part of collecting the data that we need for science verification with LSST CAM. So you can think about this as the period where we are first exploring the full scientific potential of Rubin Observatory. After the system optimization with ComCam, that gets removed and you install LSST CAM, right? But on the LSST CAM track, there's this period of the science validation surveys that comes right at the end of commissioning, right before the operations readiness review. And this becomes a period where we are focusing on exercising the entire observatory in this cycle of daytime, nighttime operations, basically exercising the ability to run in a sustained data-taking mode. And there's a menu of possibilities here. One likely candidate is basically doing a pilot of the LSST wide fast deep survey. So you could imagine in something like a month time, you could take 1,000 square degrees to 1 to 2 year LSST equivalent depth in basically all the filters, okay? And there's other possibilities. You could imagine trying to increase coverage of the LSST deep drilling fields. You could imagine picking out specific astrophysical targets or doing target of opportunity. Basically, here we're focusing on, in some sense, commissioning the survey itself. And so this is an area where there might be, more interaction with the SCOC about what is most useful at this stage of the process. Maybe I'll pause here if there's any questions.
Yeah, hopefully we're okay. Can you hear me okay? You have, sorry. Oh my gosh. You have early science synchronized with the start of on-sky engineering, but you had early science synchronized with data preview 1. And how long after the end of system optimization with ComCam does data preview 1 get released? Is it
6 months after that?
Keith and his team will take 3 months, 1 month, 1 to 2 months, etc., to take this data. Once they have that data, once we have a data set, we will start to reprocess it as part of data preview 1 or data preview 2, and that roughly is 6 months post the end of these periods. So the data will all be reprocessed. During this collection, we'll collect data, we'll pass it through the DM science pipelines, we'll look at the data products, we'll analyze them, we'll see issues, we'll correct things, we'll take more data, we'll fix bugs, we'll go round and round and round and round. And then once we get to the end of it, we will cut a release of the science pipelines and we'll say, now we'll reprocess all this commissioning data into DP1 or into DP2. Thanks.
And I apologize because I'll ask a question that was probably answered, but when do we get first alerts? Is that during the science validation surveys, or when do first alerts actually hit the brokers?
Alerts, the first alerts will come, are we planning to do canned alerts with ComCam, or is it just LSST cam? Yeah. Right. So that's, we're going to start doing canned alerts with ComCam. So that means that we'll create alerts out of the data, but it won't be in real time. It won't meet the 60-second latency requirement. And as we get into LSST cam and start to produce alerts, we'll try to approach the real-time the latency we expect for operations.
Very, very first time.
I wouldn't rely on that. I mean, it really depends on how it goes. We'll start to try to produce canned alerts. We'll try to test them, but I mean, we need to run difference image analysis, and so if there are problems with that, then maybe it will be closer towards the end. There's no guarantees that you'll get alerts from the first point of this testing, but sometime during this period, we will be attempting to produce alerts and distribute them to the brokers. I think we have to do better than best effort. I'm just not going to guarantee that you get them right at the beginning. Sorry. Oh, sorry. Mario asked if the alerts during ComCam and LSST cam were on a best effort basis. I think we have to do a little bit better than best effort because we do have to test and we do have to verify the alert production system. I just don't want to guarantee that you're going to get them right from the beginning. It's not that as soon as we've managed to produce a template, we'll start issuing alerts. At some point during this period, we will issue canned alerts. If we fail to do that, we'll have problems.
I'm looking at Eric, and I think what Mario said is in some sense correct about the fact that if we're successful in these last science validation surveys, we could be generating some real alerts. And Eric's nodding his head. That would be before we do the data preview 2. So you're right. The very first, kind of real LSST science could be from that early alert stream. Yep, it's a very good question, and thanks.
Could you repeat what that very good question was?
Mario's question?
The last one to which the response was.
Bob replied.
The question that Mario asked that I answered sometime after he asked it because we had a discussion was, is it true that the very first early science could be alerts coming out of the science validations surveys at the end of LSST cam commissioning ahead of the data preview 2? And the answer is yes, that is a possible, maybe even likely scenario.
So the underlying images would or would not be available through the science platform at that time?
Would not be available.
So only the postage stamps would be available in that scenario?
Exactly, the alerts. Let me add one thing to Gregory's last question. We had a discussion earlier today, and I'm not going to go into any details. You can hit me up later about a hold time on images coming out to the community generally in the regular survey being 80 hours after images were taken. Alerts will be available, alert data, postage stamps, 60 seconds. It is, since the SV survey is the end of this, we will treat like operations. I think we can make the case that those images should be available 80 hours after the alerts come out in SV. That is not the case, certainly, for anything before in commissioning. Those data will be within the commissioning team for 30 days and not released outward of the commissioning team.
Thank you. So it was said in an earlier session that LSST's scheduling and the fields that it will be looking at will be published so that people can help coordinate follow-up, for example. Is that going to be true in the science validation surveys? Will that be made available in advance for people who want to coordinate follow-up or plan follow-up?
Let me ask a question. Do you mean the specifics of exactly which field and which filter? I mean, is this a question? Is this a question about the actual telemetry, or is it a question about the strategy? Do you see this distinction?
The question is, during this end phase where we're hopefully in science validation surveys that look a lot like regular operations, will we be broadcasting, as we will in normal operations, the survey schedule? So what we're going to do in the next few hours. I think it's an excellent question. I don't think we have an answer right now, but it sounds like the kind of thing that we would want to commission as we go forward into operations. So I would say definitely that's something that we should take a look at, and more likely than not, unless things get terribly squeezed for some reason, that is something we would target to be available because we want to know how it works.
In a related question to that, will the telemetry be available? So, for example, what current fields you're observing or what fields you've just observed?
I think Bob just answered that question. That I think this is a Bob. This is a Bob question here. Yeah.
The question is, will the telemetry of what we've actually observed be available to the community during this period of the end of commissioning and science validation series, surveys? Yes, the telemetry that we produce by doing the prompt analysis will be available in the science platform. Whether that's actually available at exactly what time through this end phase, I'm not 100% sure. But it should be, again, something that we would want to have done and commissioned by the time we hit full operations. Where's Chuck Claver? He should be answering these questions.
Yeah, that's sort of more of a how we. Do you have any more questions?
I'll just mention very, very quickly something I should have mentioned at the start, is that the design of this was informed by the commissioning notes that the science collaboration submitted back in 2020. So I just want to say thank you again for the science collaborations that submitted that information. It was really valuable for the planning of this. And so I just to emphasize that your input is being used to design this. And while we can't guarantee this is exactly the plan, hopefully it gives at least some sense of what our priorities are, and these will, when it comes to the actual time of implementation, we will have to think about the details of, exactly which fields, and we just won't know until we actually get within a few months of going on Sky.
Thank you, Keith. Okay. I put this on for you. I can talk. You can talk to it. I don't mind.
Apologies, but for those that don't live in the desert, could we just pause for like a couple seconds and thank the universe for this rain? It's incredible. Key milestones. So we talked about the schedule. We talked about when the data previews come out. That's really what this slide is speaking to. These are the same things coming out. Right now, we have successfully delivered the first of the simulated data for data preview 0. That's ongoing with the community. And then we've been talking about ComCam and LSST cam and data previews 1 and 2. Those are coming out on the schedule that you see there. We've also noted that operations will begin. This basically is when we complete with the construction project, the operations readiness review, which will be a joint agency review of the status of the project and how it's accomplished or meets all of its requirements and specifications, plus 1 day. And so There's a second milestone, which is the start of full survey operations. In an ideal world, we start full survey operations basically on that same day. In a world where system validation or science validation is challenging, we may have to start the survey formally some period of time a little bit later than the actual turnover to operations, that we are now just an operations team running the facility and going forward. I hope that's clear. Maybe we should pause for just a second, because it is an important distinction. Operations will go once the project has demonstrated to the agencies that they have completed the project, that they've completed a successful review of what they were supposed to deliver. Operations then begins. Whether there's a period after that where we're not quite ready for just pushing the button and going full on the survey remains to be seen, how we enter operations coming out of these science validation surveys. There's a question in the back. I'll just answer.
So, hello? Sorry. So thinking about Keith's talk this morning, and then those, the science unit working groups and the various, group topics that were discussed, how does the success of those groups completing their work actually then influence the operations timeline? Is there an individual different set of metrics that you're trying to establish to prove, for instance, to the funding agencies that you've, met your various requirements?
Not sure I quite got the question. Did Leanne, did you get it?
I think, if I understand correctly, I think what you're asking is, do we have a different set of requirements within the operations project? Once we get into operations, do we have a different set of requirements to those in the construction project that led to completing construction that leads us to the decision to start the survey or not? Is that what you're asking? Mm-hmm. Right, that Keith mentioned this morning. Okay, do I understand your question correctly? Yeah, okay. Understand it now?
I didn't hear the last part, so go ahead.
And so then the last part is Keith in his session this morning on science validation and verification presented these science units, which are sort of science themes around which we want to organize the commissioning people plus the in-kind contributions who will work with the commissioning team to verify and validate the system as built and to meet our formal requirements, and also to validate we can do the science. And then that leads into the operations readiness review and construction completeness. And so is the requirements for us going from this milestone here, where construction hands over to operations and operations starts, to us going to survey starts, do we have different requirements to the requirements that led to construction completeness?
Got it. So anything that Keith said, if that leads to the actual fulfillment of a requirement for the construction project or some key specification, that has to be done. And so we'll assume that that is done as we go through the operations readiness review. At the time of the operations readiness review, the operations team itself will also play a role in that, not only to accept and advise on what is being delivered to the operations team, but to show that the operations team also has a plan, that they're ready to operate the facility, and we have a staff that's fully filled out and trained and ready to go. So those are things that are on our side. How we exactly decide what needs to be done to start the survey is a little bit more of a squishy question, because you can imagine that the construction team delivers a perfectly valid system that meets the requirements to deliver science-ready data in every way, but we haven't gotten through all the things we wanted to get through in commissioning in the end in science validation surveys. So the question would be, is there something that was in there that's super valuable to the operations team, to the community, to understand how to do correctly before we start the survey, that we would then think about as early operations activities? But we absolutely have to finish the construction project and meet the agreed upon criteria and specifications. And to the extent that anything Keith is doing in commissioning is required to do that, it has to get done by definition.
Any more questions? Yes, okay, is your plan to go through?
Okay. So this is how we've begun thinking about early science and how to plan for it. Okay, we've been talking a lot about what early science could be in actual, looking at the sky and what we're doing type of ways. But how do we plan for early science when there's so much uncertainty in how we get over the next 2 years and into operations? Because obviously we are just entering the really most challenging part of the whole project to put it all together. Everything's up there on Cerro Pachon. The camera's almost done in California. It's going to get shipped pretty soon, but we got to put it all together and make it work. So we got 2 years, super challenging. Plan A is that everything goes great and we totally execute everything that Keith told you about in the commissioning and science validation surveys, and we basically just keep rolling into operations into data release 1. Now remember, this is a framework. This is something we're trying to put out to help get your input so we can make the best scenarios as we go forward. Did you want to jump in now?
Yeah. There is a question from Meg on Blue Jeans. Meg, do you want to unmute and ask your question now?
Yeah, I'm a little confused about these scenarios because to me, if you haven't finished the things you would do in commissioning, then you're not done. And so you can call it operations, right? But that still means that you require engineering. And so I guess I'm very confused that we're like, well, we would do this, we would have an option A, an option B, and option C. My answer would be is that if you know what you need to do to commission the telescope, right, to the ability that you know it's ready, that's the things you do. And when you're done with that, you start the survey. And so if you're not done with that, then you'd continue it, right? And so, right, and you would say we're having X number of nights of engineering, and maybe it's a decision of whether you're running the survey because you're generating science quality data. But I guess I'm really confused about this. We might do some other things in between while we figure out how to optimize the system, right? And to me, it sounds like if you're not ready, you would execute Keith's plan. And so can you kind of walk me through why that, or all of us through why that's not the case, that if it was Keith's plan's not done, you wouldn't just execute that, and when that's done, right, because that's what you're saying proves projects saying everything's ready, why you wouldn't just do that and start running the scheduler, right, or interspersing Keith's plan in between the scheduler running if you're getting science quality imaging. Like, why make the community spend extra time coming up with proposals and ideas, et cetera, right? Like, you know what I mean? When it's such a sliding scale. So can you explain a little bit what's the thinking behind that, rather than we didn't finish these things, we've just finished the timeline and get this, we get observations.
Ed Ajar from NSF wants to make a comment, and then I'll try and answer your question, Meg. Thanks.
Yeah, maybe this will help a little bit. I'm trying to help Bob. We have to help each other on this kind of question. But think of it for a second, because Bob hasn't given it to you from this angle yet, but I'm thinking, just think of it purely from the operations standpoint. The pre-operations began in October of 2018, you can imagine. That's almost 4 years ago. And you could say, well, what the heck have they had to do, right? I mean, and look at all the things that they've been doing, delivering to you data preview releases, planning everything that's going to happen, everything that they're going to need to actually start the survey. And see, that's the real question. So the real question that Bob has is, when are we ready to start the relentless 10-year survey operations? That is not the same thing as, are we done constructing? Have we delivered everything? So the construction team has a very different question, and NSF has a very different question and asking, when are they done with construction? Did they deliver everything that can now support the science requirements document? Did they complete everything they promised they would do in their project execution plan? Part of all of that what was not funded was all this pre-operations activity. That wasn't funded on construction, because a whole new team has to basically take over and do that. So that's why there's two things happening in parallel for a while, and now they're going to be working, more and more intensely and right on top of each other, essentially. And the question is, when is the survey ready to operate? So that's the question that Bob will be focused on, and that's what this A, B, and C scenario is about. From construction, right, they have a certain amount of money and a certain amount of time, and those two things are inextricably linked, right? Because eventually you will run out of money, and that will determine when you're out of time too. So they have to sometimes, in our plans, right, there's scope that's promised or expected, but it's linked to a total project cost. If that scope can't be delivered in total, they have to think about de-scoping, and so does NSF. is there something that can be de-scoped from their plan that's okay with us, because in the end they're going to deliver something that will still give us the science that we all expect. So that's what the construction team is focused on. That's what I'll be focused on when I'm thinking about construction. Have they delivered what they need to deliver so that Bob can take over in operations and figure out when and how to deliver the survey? So that's where there's a difference here, and that's why where we end with construction, well, we don't know. All of these, any one of these three scenarios will work. Plan A, as Bob has it defined here, that's the best case scenario plan. We all hope it happens that way and happens in almost 2 years from right now. But, it's tough. Things happen, right? There are known risks that are part of the plan, and we can get very unlucky or we can get very lucky. And the plan kind of has both of those things factored in to the best that we can estimate them. You got an excellent team both on construction and on operations. So I don't know if that helps with the perspective, but that's the way I look at it. So
yeah, I guess that's not my question. My question is that if this is, why wouldn't you take Keith's plan and just shift it into operations and say that's now operation? This is the minimum to guarantee that the telescope would work for the survey. And so if we can't complete it in construction, we move it to operations and just shift it. That's, I guess, my question of when you. I guess that's the question I'm trying to ask. Right?
Okay, that's right. Maybe I can answer that, and if I can't, Bob will do better, probably. I think for me, the answer to that question is that the construction team has, again, a different perspective exactly on what they have to deliver, and they have put plans in place to the best everybody's knowledge can produce at this point. But 2 years from now, what that original plan was may evolve quite a bit. And it might be, this is good enough, right? Because actually, we've already evolved away from the original project execution plan and all the details. And so some of that has already been modified quite a bit. So when the operations team looks at it, they may have a different plan that'll be better and more tuned to what system has already been delivered to them. And that's why it's not just as simple as saying, well, just do what was already planned, because they know what things we think we need now, but in 2 years it may look a lot different. So that's my perspective. I appreciate having an opportunity there. Hope it helps.
Thank you very much, Ed. Meg, I'd love to sit down and talk with you, and that might be the best, but I would say that I think we're not that far apart. We both understand that the system could be delivered and be scientifically viable, and yet we're not quite ready to start the survey, and we'll do whatever we need to do in operations to make sure we're ready to start the survey. I would say the place maybe that's causing confusion, and the reason that we have these, instead of just a simple scenario B like you're talking about, why we are breaking this up, is I think there are, depending on exactly how we come out of commissioning, there are perhaps different ways we want to think about somehow providing data for early science. Otherwise, if we just push everything out, the community waits for more than a year after we've taken over the telescope. And I think that's one of the things that we're, I'm not trying to say we have it completely figured out, but that's one of the things we want to have this discussion about, hang those solutions on this framework and see where we end up. That's, I think, the big difference between what you describe and what I'm trying to describe.
Meg, do you want to respond to that, or has that answered your question?
No, I think it gives a lot of clarity. Thanks.
Okay, thanks. We've got another question here from Eric.
So following up on Meg's point, I don't fully understand how Plan B works if it's 3 months. If it's 6 months, I can see what happens, because it's kind of like a special survey mode, and that leads to your DR1, and then you'd start your standard survey operations for the whole wide fast deep after 6 months and figure out what to do with the subsequent data releases. But if it's 3 months, would you then release 3 months of the special mode and 3 months of WFD as DR1? It seems like you're really just extending the science verification by 3 months and should do like a data preview 3.
Well, I think those are excellent questions, and that's the kind of thing we're trying to get. I mean, I think everyone should have come out of this discussion so far with the uncertainty of what we're going to get exactly when we go into operations is pretty large right now. It will shrink as we go forward. And exactly what those time frames, we could say 3 months, 6 months, 2 months, 1 month. We don't really know exactly what that means. Your question is a good one. What does DR1 really look like? That's the kind of thing that we will, as these uncertainties shrink and these plans crystallize, we will try and jump onto one of these tracks and then really flesh it out and what it means. And we'll do that continually with you. So we try and get the best outcome. And the best outcome is we get the survey started as soon as we can, and that we get early science data products as soon as we can. Those are the two main goals.
Thank you.
Do we have any other questions? Any questions from Blue Jeans? No? Okay.
How are we
Karen.
doing on time?
Do you think we're okay? Oh, what time did we finish? Was it 3:30 till 5, I think, our
I
session?
think so. Okay.
Yeah, you're fine. Go ahead. That's just how we
Okay.
interact with the SCOC.
Yeah. So getting to the optimum of what goes into these data previews under these different scenarios is obviously in detail something that the SCOC is going to have to really help us with. They will deliver the phase 2 or the next version. Actually, I like to call it the final initial version of the cadence at the end of this year. And you can, if you download these slides, you can check out the more information on that. So they will continue to solicit input from the community on aspects of the cadence that are under active discussion right now, including the early science. And so I will confess that we have been working as an operations team thinking about early science. We've developed this Plan ABC framework that we're trying to flesh out. The SCOC has been working, and not that we're unaware that they're working, but we haven't really connected those two things in detail yet, and that's an outstanding thing to do. So once we start thinking about what these different scenarios might look like, what does it actually look like under a given set of conditions, how are we going to hit the sky and which filters when, that's the kind of thing that we need to work with the SCOC on and flesh out.
Okay, do we have any questions on early science and the SCOC interaction? No, anything from Blue Jeans? No. Great. Isn't this thunder amazing? I used to get this where I was growing up in Northern Australia. I haven't heard it for years. Okay, let's change gears a little bit, move on to alert generation in year 1. Stand up here. So another aspect of early science is to attempt to increase the number of alerts we can generate in year 1. So just to remind people again, I said this before, but I'll remind people again. When we start operations, we won't have templates for all filters, or for many filters, in fact, for all the different pointings on the sky, with which to create. We won't have images, with which to create templates which are needed for difference image analysis in order to generate alerts. So we cannot start alert production. We cannot start to issue alerts at full scale or full fidelity in year 1. And if we come out of commissioning with no images that are science quality that we can use to make templates, we'll have no alerts at the beginning of year 1 at all. We would have to wait for a data release processing, which would start 6 months later and which would finish a year after the start of operations, and then we would have alert production in year 2. So we wanted to try to rectify this situation and at least try to produce some alerts in year 1 to enable early science. And the DM science team made a study. You can see it here. It's in DMTN 107. We looked at the options for alert production in LSST operations year 1 and came up with 2 scenarios that we could use to increase the number of alerts we get in the first year of operations. One is to use the commissioning templates, to build templates where possible from all science quality commissioning data before the start of year 1, and then use them to generate alerts during year 1 itself. And we would work with the commissioning team to try to, where commissioning activities were agnostic to filter and pointing, we would work with the commissioning team to try to optimize the images we would get to build templates for year 1. And then in year 1, the plan is to build templates progressively from data obtained during year 1, say on, for example, a weekly or a monthly timescale. That's to be decided. It's just as an example. And then to use them to generate alerts for the rest of year 1, either instead of or in addition to using the commissioning data to build templates. And so this way we start to increase the number of alerts that we produce during year 1 from the year 1 data progressively over the course of the first year of operations. Pause there and ask if there are any questions on that.
Thanks, Leanne. Do we have a quantitative understanding of the impact that the lack of templates will do? Do we have a quantitative understanding of the impacts of the lack of templates in year 1? Right. So basically, Do we have a quantitative understanding of the lack of impact of the impact of lack of templates in year one? So because effectively for science relying on differencing, that means that some fields are, it's as if they're not observed until enough data is collected to do the templates. And in principle, we could run, I guess, OBSIM simulations to understand what does that mean in a number, say the total number of alerts or total number of asteroids discovered and so on. Do we have a sense for, is it 50%? Is it 90%? Is it somewhere in between?
Eric, do you have any? I don't have an answer to that question, but Eric might.
No, we don't have that answer. That's the study we need to do. I think Leanne's emphasis here is that, incremental templates allow us to do some alert generation in year one as opposed to a baseline of none. There are tricky technical pieces about understanding when to build templates from the as we receive, and I think that indeed looking at OPSIM to guide us in terms of expectations for data quality and seeing sky coverage, all of these sorts of things will be important.
We were talking about this yesterday. I think it's true these are all scientific decisions, not technical decisions. There's no reason why we can't build a template as soon as we go to the second time on that part of the sky. Eric's feeling is that probably you're not going to want that, and that's why we should do the study, just because it's hard to interpret. But it's not that we couldn't, it's that we don't think it's the right thing to do, and that's where we should have a conversation, or the SCOC should, or somebody.
Yeah, that's kind of why I'm asking this question, to get a feel for the timeline on when will we know, and because that's the information that will allow us to make a decision on how many images to go into a template. And the second reason is, how do we modulate our messaging to the community? Because there's some science that's very front-loaded, and there are lots of discoveries to be made in year one, assuming templates. So we need to start to be telling the community, well, actually, multiply that by 0 point something, and like at what point do we know that's something?
No, they're good points. There's a question at the back. That's Željko, I think.
Thanks, Leanne. I think we did not explain to this audience what happens if we go with incremental template building. So you have template, you have that image, how quickly you can access it as a user. Alerts will be coming, of course, but I want to know what is in the static sky in that position, and if you assume it wasn't covered by science validation surveys, then I have to rely on other data sets or wait until it comes out in year one, or maybe there is some way of making this available through Rubin Science Platform, etc. These are co-edited images, but also sources. When you find sources to do astrometric calibration and so on, that would be extremely useful information for doing science. And we did not explain whether these sources will be available to users through Science Platform, or do they have to wait until DR1 to see those sources for the first time, or how will that work in practice?
Are you referring to sources through difference image analysis? Yeah. 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 So we would.
When do you get? So there is new part of the sky we did not cover in commissioning. We started survey. We covered it n times. We built template image so that we can produce alerts. Alerts go out, that's clear. What is unclear is when do we publish these images, and what's even less clear is these template images, and what is less clear is the information about sources detected in these images that would be useful for science. Do they get loaded in the Rubin Science Platform at some point and we can access it? Or if I want to know, say, counts of galaxies around my alert, do I have to wait until DR1? Is there a way to do some science of that type prior to DR1? What is the plan for RSP?
So the prompt products database will be updated with all the information from the source detections, the 24-hour data products. They will come out for all the associated prompt products will come out for those sources detected in difference images for which there are alerts. So you'll be able to access those 24-hour data products. And I'm not sure, Bob, what's the story on image release?
So then in 80 hours, you'll have the process visit images. You won't have coads until data release 1.
Yeah, so all the other static sky science is data release 1 because it goes through data release processing.
But I mean, the short answer is you will have an image fairly soon after that alert came out that you're interested in.
Yeah.
Eric? Eric says yes.
Yeah, the template, but the template for the detection is also part of the alert packet.
It's part of the difference images, right?
Yeah.
So that'll be available in 80 hours too.
It will be. No, the only the only analysis that will be done in the overnight processing is difference image analysis. So if it's not a changing, moving, transient solar system object, it won't be picked up in that analysis. And so the analysis of all the static sky objects, that comes through data release processing. And that will come out in the first data release. Mm-hmm. I think so, yes, because you won't be able to calculate that till you have a data release. Yeah. There's no DR, so you've got no reference to calculate it from. Yeah. Sure. Okay, yeah, it's a good point. So the prompt products database will be updated within 24 hours, but it won't be able to include everything in the first year that you'll be able to get in future years once a data release has become available, and you can compute all of the quantities, like, for example, the distance to the 3 nearest stars and 3 nearest galaxies.
So this is another great example of a good question that we don't have a perfect answer for yet. I will just say that we will have all the information Jelko wants you to have right away. It just doesn't show up in our current plan as a data product that's available in 80 hours, right? We have to do the source detection on the process visit images. But right now, the scheme is that won't show up for the non-transients until the data release. We could consider, given resources and time, whether what Jelko is suggesting is sufficiently valuable to make another addition to the data products.
Okay.
Yeah, so in that vein, could the SCOC recommend, say, a special static science product that would be available before DR1, let's say some, interesting part of the sky that would allow some early science to get done, or is that off the table?
I don't think it's off the table, and certainly listen to anything that the SCOC comes up with. I think this gets into the whole thing about really understanding what's going to be available when we have a better understanding of how we're emerging out of commissioning. And if it turned out that we weren't going to do those great science validation surveys, which, by the way, that would be part of this that you're talking about, right? It would be 6 months after that finishes, so early on in year 1 or midway through year 1, we would be giving the community an amazing data set through DP2. If that doesn't happen for some reason, then I think we ask the question you just asked more, and we try and look to what makes the most sense with time and trying to keep up with the data release 1, but also trying to get the community, all the community, transients and static science as soon as we can.
Do you have any other questions?
By the way, it helps if folks introduce themselves when they ask a question. That was Knut Olsen, who's actually part of the SCOC. And you've heard a lot from Mario Jurek and Jelko Ivasic, Franz Bauer.
Maybe I just want to add something to what I just replied to Jelko. I said we wouldn't be able to calculate things like distance nearest galaxy, but if we had that information from the commissioning science validation surveys, we might be able to if we'd covered it in commissioning. But it would be very, very, very small. So we could use the data preview too, but it's not going to be a lot. Okay, any more questions or any other questions on blue jeans? Okay, we've probably covered a little bit of this already, but I'll just quickly go through it. These are the details of incremental template generation, how it will be done in data management. The original baseline, our original requirements, in the original requirements, we would create templates for difference imaging as part of data release production, so that would be annually we would produce them. We modified these requirements following the DM Science team's study on options for alert production in year 1 to state that the DMS shall periodically create template images in all pass bands outside of the context of data release production. And so this is what enables us now. We now have a formal requirement to ensure that this is a capability within our system to run template generation whenever we want to run it. The cadence at which we run it is TBD and will be decided much later on. In our current baseline, and according to our requirements, templates in year 1 will be made with at least 3 images and 5 in subsequent years. This is due to the requirements on the amount of noise that a template image can contribute to a difference image. I think that's the topic that Robert just touched on and Mario just touched on as well. Also note that templates are not necessarily built from the first N images that are collected. There will be quality criteria that these images need to pass, and if they're not of sufficient quality, TBD, they won't be used to generate a template. Also note that with incremental template generation, once a template is produced for a sky position and filter, it will not be replaced until we run data release production. It's just, it's a little bit too challenging, too much for us to constantly be updating our incrementally generated templates over the course of the year. So once we've done one for one region of the sky, it stays there and it will not be repeated until data release production generates new templates. Okay, any questions on that before I move on? Because we're going to change gears a little bit. Nope. Okay. Okay, so this is about community input to early science. So I think the key thing is here is that we want to listen to the community and we want to discuss with you aspects of early science, how we develop the early science program. If I go back to the 3 scenarios that we discussed in Plan A, we will need to devise a strategy for template generation that balances a trade-off between the various factors, such as a smaller area with more filters or a single filter over a larger area. It will not be possible for us to survey the whole sky and all filters and generate templates by the end of the commissioning period. And several of the science collaborations have already written technical notes, research notes, and published these and argued for why they might want a larger area, why they might want a specific area, why they might want 1 filter, 2 filters, specific filters. And this is very useful information for us. And we will use this and we will consult with the community to devise what our program for generating templates would be. That's in the scenario of Plan A. Plan A, I just remind you, is that we start operations, we move into operations and we start the baseline survey almost immediately. Then the only thing we really have to do is work out how we're going to incrementally generate our templates. In Plan B and C, in addition to template generation, we would also need to devise an observing strategy for early science. And this is what Bob touched on before when he was talking about Plans B and C. Should this just be the LSST cadence? Should it be what we were planning to do with Keith's plans in commissioning? Do we just carry these over or do we do something else? And as Bob mentioned before, this is something that we would think about in order to maximize the opportunities for early science and make sure that the community has something valuable to work with in the year it will take to develop, to produce data release 1. Questions? It is a bit of a maze. I know, that's right. Terrible thing about these meetings is too many cakes.
Very dangerous cakes too. So the point I just wanted to make here is whatever you might think about doing that alters your year 1 strategy to get templates the way you think you want them, it's really important for those of us interested in doing cosmology and galaxy science that you end up with a uniform survey again by the end of year 1.
Thank you. That's a good point. Any other comments or questions on this?
I mean, I don't think we're going to end up with a uniform survey in every filter by year one. So are you talking about uniform in how complete a sense?
So, I mean, if you think about the natural non-uniformity level of doing things in the standard wide, fast, steep cadence at the end of year one, we want to be roughly there. It's not perfect, but it's not like, this area of sky has no G-band data.
Okay. Let me rephrase my response, because I'm thinking that I think you actually said year one, and I was thinking data release one. And of course, we will be processing 6 months of data for data release one, but we will continue observing for all the way through, and of course that will go into the next data release. So yes, yeah, got it.
Yeah. Any other questions? Anything on blue jeans, Eric?
Mario asks, once the survey officially starts, will all PVIs be available 8 hours after being taken, irrespective of whether alerts were made with them or not?
Yes, I believe so. I was trying to parse the question, but basically, yeah, we will put out all those images will be available as a data product on the science platform when they're produced and 80 hours has passed. The difference images, the PVIs, the templates I said earlier are 80 hours, but the templates really are whenever the cadences that they're available, they would come out on some logical time scale.
I asked this because early on there will not be templates. So you're saying, 3.5 days into the survey, the first PVI hits the servers and one can potentially download it and look what's in there.
Yep.
Excellent. Thanks.
I think I know what Mario's thinking. Any further questions? I don't think so. Okay, Bob, this is you. I think this is our last slide. Yes.
That's been a great discussion so far. Yeah. Here, I'm just going to talk on the. I'm going to talk on that.
I'll walk around.
Timeline for early science decisions. This is a good point. So first of all, you can see the level of vagueness that we have crafted this framework with, the fact that we need to come back to the SCOC and other stakeholders, the community, and understand what goes into this. So that is what we're going to be actively working on hard in the next months and year. I think it's good to remind ourselves what's happening. The commissioning camera will go on the telescope soon, but the mirrors won't get there, and that period of data taking won't be done for about a year. Basically, that's actually a good thing. If I can say in about a year, we should have done the commissioning camera work. That's not very long from now. We only have 2 years left. What that means is the next year is where we're going to try and get all this stuff figured out, because then we will have finished the data taking over a fairly short period of time with commissioning camera. We'll know a lot more about the system. We'll be in a position to start making decisions, but we'll have a shorter time to make them. So when we ask when will these decisions be made, we will keep you apprised of the survey cadence optimization committee's work and when it comes out at the end of this year. We will talk to you at the AAS about where we're at with these decisions and how this framework is developing and how we're connecting to the SCOC and what that means. We'll give you an update on the project status and what we think is holding. But a lot of the details of exactly how we're going to get, move from what we learned, how the telescope works with commissioning camera, then putting on LSST cam, and how we're going to end up just looking forward 1 year from there. We're still going to have to wait a little while to be able to tell you exactly when we're going to freeze and try and develop, scenario B instead of scenario A or whatever. But we'll do it as soon as we can. And I think the time scale for learning a lot more should be, you'll learn what we're thinking, and we'll be talking to you over this next year. And in about a year from now, we'll have to be starting to make real decisions about what it looks like getting through the first year of operations.
Questions?
This is very relevant to that. Meg asks, there's been several mentions of asking or wanting community feedback or input. How is operations and the STOC envisioning formally getting that feedback?
So certainly just having the meetings like this and the AAS when we're conveying what we're up to is one place to get the feedback. We have just instituted the users committee, and we can expect they will become more visible within the community and actively soliciting input. We have the Science Advisory Committee, and they will be actively working with us on these topics. As far as getting specific input to a committee like the SCOC, I think that's up to them to decide what input would be most valuable and how to get it, and then we'll support them in doing that. So I think there's a variety of channels. I think if you think that we're not listening or there's something we're missing, you should send me an email or call me up and let me know.
Or you could go to the community forum.
Thank you. Leanne's right. Go to the community forum.
Yeah, we have on the community forum, we have a category for early science, under science. There are some posts here, but please do feel free to ask us any questions, bring up any topics, start any discussions you want on early science about anything we've discussed today. Absolutely anything. We're listening, and we'd love to get your feedback this way. This won't be the only way, of course, that we get feedback from you. And I'll just also say that, again, that some of the science collaborations wrote research notes. I know Meg, who's asked a few questions today, she, I think, actually started this with the Solar System Science Collaborations note, was extremely informative, gave us a lot of good information as to what could be useful to maximize science for Solar System. TVS followed up with a couple of research notes as well. The desk have contributed to some discussions here about what's very useful for them in terms of, say, a template building program or what would be useful in the data previews. So those were very useful. Thank you for putting those out.
Thanks, Leanne. Let me add, I'm glad you mentioned the science collaborations because that's another great channel for feedback, and a lot of the input and the discussion you've heard today are from leaders in the science collaborations. So if you're not in a science collaboration, join one. Start giving your input. And then we as the observatory, Rubin Observatory, both construction and